Imagine you're flying at 30,000 feet in the air and suddenly your GPS system goes down. Panic sets in. How do you navigate? How do you stay on course? Believe it or not, GPS jamming is a real problem, and it happens more often than you think. From rogue signals to powerful military jammers, the risk of losing satellite navigation is growing. But what if I told you there's a mind-blowing new solution that could keep planes on track, even when GPS fails? Enter quantum technology. It's changing the game, and it might just be the future of aviation. Let's dive into how quantum systems are about to revolutionize flight navigation and keep us safe in ways we never imagined. For years, we've relied on GPS satellites circling the Earth, sending signals to our phones, cars, and airplanes to tell us where we are and where we're going. But what happens when that signal is jammed? GPS jamming occurs when rogue signals interfere with or completely block GPS signals. This can happen in a number of ways, from GPS jammers that criminals use to more serious military operations designed to disrupt navigation systems. The problem is so real that it has been causing headaches for aviation professionals worldwide. In fact, there have been numerous incidents where airplanes have lost GPS signals mid-flight. It's not just inconvenient, it's potentially dangerous. Imagine being in the cockpit of a plane, thousands of miles from the nearest airport, and suddenly losing all navigation signals. It's enough to give any pilot nightmares. So how do we deal with this growing problem? Here's where it gets interesting. Enter quantum technology. Unlike traditional navigation systems that rely on GPS signals from satellites, quantum systems are based on the fundamental laws of physics at the smallest scales, quantum mechanics. These quantum systems, which use a phenomenon called quantum entanglement and quantum sensing, offer an incredibly precise way of determining position and movement without relying on satellites. They're not susceptible to interference or jamming because they don't rely on external signals. They work by exploiting the quantum properties of particles, like atoms or ions, to measure tiny changes in their environment. What does this mean for aviation? It means that even if a plane's GPS is jammed or spoofed, a quantum navigation system could still provide an accurate location fix. This kind of system works in a completely different way, and that's what makes it so revolutionary. So how exactly do these quantum systems work? Here's the breakdown. Quantum sensors can detect extremely small changes in things like magnetic fields, acceleration, and gravity. By measuring these tiny variations, they can track the motion of a vehicle with incredible precision without needing GPS signals at all. One popular quantum navigation method uses something called a quantum accelerometer. This device measures the acceleration of an object, and since we know the initial position, it can calculate the position and velocity of the object over time. The accuracy is so high that it's been compared to measuring the distance between 2 points with the precision of a single atom. It doesn't stop there. Quantum systems can also be linked together in a process known as quantum entanglement. In simple terms, entanglement means that two quantum particles can become linked in such a way that the state of one particle immediately affects the state of the other, no matter how far apart they are. This allows for more precise, real-time tracking, even in the most chaotic environments. You might be thinking, okay, quantum sounds cool, but why is this such a big deal for aviation? Here's why. Aviation is one of the most safety-conscious industries in the world, and rightfully so. Even the slightest glitch in navigation can be catastrophic. If traditional GPS fails, pilots are left to rely on backup systems like inertial navigation systems, INS, which aren't nearly as accurate as they should be over long distances. Quantum navigation, on the other hand, doesn't suffer from the same errors. It doesn't rely on satellites, so it's immune to jamming, interference, or even things like solar flares that can disrupt GPS signals. Imagine how much safer flights could be if planes could always find their way, even in the most challenging conditions. What's more, this technology could completely transform aviation by allowing aircraft to operate more independently. Pilots could navigate accurately without needing to constantly rely on ground control or external systems. This means fewer chances for error, faster flights, and overall safer skies. Right now, quantum navigation is still in the experimental phase, but researchers are already making huge strides. The race is on to develop quantum sensors that are not only accurate but also compact and affordable enough to fit on an airplane. Several companies and universities are already working on miniaturizing quantum systems so they can be deployed on aircraft in the near future. And while these systems are still being fine-tuned, it's clear that they're going to revolutionize aviation. In fact, quantum sensors are already being used in military and aerospace applications to track missiles, satellites, and even submarines. Within the next decade, quantum navigation could become a standard feature in commercial aircraft. And with that, we'll see a future where planes can navigate through the skies with pinpoint accuracy, even if GPS is knocked out of commission. But it's not just aviation that will benefit from quantum navigation. The potential applications are vast. From self-driving cars to autonomous ships and even drones, quantum sensors could make a massive impact across industries. However, the introduction of quantum technology also raises important questions. Will we be able to keep up with the rapid pace of this technology? How will it impact security, privacy, and control in the future? These are important conversations we'll need to have as we embrace this next leap in technological advancement. So, while GPS jamming might be a real problem today, quantum navigation offers a glimpse into a future where we won't have to worry about losing our way. It's a future where our systems are more secure, more reliable, and more accurate than ever before. If you're as fascinated by the future of technology as I am, make sure to like, subscribe, and share this video. The world of quantum navigation is just getting started, and the sky is no longer the limit.